Hello, welcome to this 4-video series consisting of 10-minute lectures, each where we will be learning all about image enhancement. It'll be very beneficial to take running notes while watching each lecture for easy revising. So, before starting, here's the roadmap regarding the topics that will be covered in these lectures. This first lecture will be all about the basic definitions, terminologies, and, in general, about image enhancement. We will delve into more specific topics in the other lectures. The second lecture will cover enhancement by point processing. The third lecture will cover image enhancement in spatial domain, and the fourth lecture will cover enhancement in the frequency domain along with color image processing techniques. Image enhancement is the process of improving the visual quality of a digital image to make it clearer, more vibrant, and easier to understand or analyze. It involves using various techniques and algorithms to adjust the brightness, contrast, colors, and details of an image to make it look better or more suitable for a specific purpose. Think of it like editing a photo on your phone or computer to make it look nicer before sharing it with others. You might adjust the brightness and contrast to make the image clearer, tweak the colors to make them more vibrant, or sharpen the details to make the image appear sharper. The enhancement doesn't increase the inherent information content of the data, but it increases the dynamic range of the chosen features so that they can be detected easily. Here are some definitions or terms that might help along this series. There are many places where image enhancement greatly benefits us, but just as a reminder, let's take a look at an example. You can see in the image shown that the first picture on the left is blurry, and it is hard to make out details regarding the entities in said picture. Now, if we apply some image enhancement techniques, we can see on the right picture that it is more clear, stable, and there is more detail, which allows us to infer information from the picture. There are a huge number of cases where image enhancement is really useful, like medical imaging, satellite imaging, photography, surveillance systems, forensic analysis, and many more. Now, let's get into the nitty-gritty. Image enhancement can be based on either spatial or frequency domain techniques. The spatial domain refers to the direct manipulation of pixel values within an image. Techniques in the spatial domain operate directly on the image's spatial coordinates and pixel values. The operation can be formulated as g of x, y equals t of f of x, y, where g is the output, f is the input image, and t is an operation on f defined over some neighborhood of x, y. According to the operations on the image pixels, it can be further divided into two categories: point operations and spatial operations, including linear and nonlinear operations. Point operations refer to simple operations performed directly on individual pixel values within an image. These operations modify the pixel values based solely on their original intensity levels, without considering neighboring pixels. Point operations are also known as pointwise operations or point processing. Spatial operations refer to operations performed on images where the output pixel value at a specific location is determined by considering the values of neighboring pixels in the input image. These operations involve applying spatial masks or kernels to the image, where the mask coefficients define the operation to be performed on the pixel and its neighbors. Spatial operations are used for tasks such as blurring, sharpening, edge detection, and noise reduction, among others. They take into account the spatial arrangement of pixels and are often used to enhance or modify specific spatial features within an image. And the other image enhancement technique, frequency domain, involves an image from the spatial domain to the frequency domain, where image properties are represented as spatial frequencies. This transformation is typically achieved using the Fourier transform or similar techniques. In the frequency domain, images can be analyzed and manipulated based on their frequency components, allowing for operations such as filtering, smoothing, sharpening, and noise reduction. More details will be explained in the other lectures. This will hopefully give you an overview regarding image enhancement and what we are about to learn.